So looking at this one with the given angles and giving you that depth of 10 centimeters or 10 millimeters. I left labeled as a centimeter, so we can go with that. What are dimensions A and B? What do you come up with for dimension A? 30.78. And B?
23.56.
Okay, so if we look at those, the one question I want to ask, do those make sense? 23, not 43? Okay. Perfect. Now it makes a little more sense. Can you tell me why? Yeah, this one has to be longer because this is a smaller angle. Since that's a smaller angle, that means this has to be a longer setback here to give you the same 10 centimeter height over here. So now that we have those dimensions, we need to figure out what it is we need to do with this in order to machine it. Before we were talking about drilling holes, compound angles and drilling holes. And in that case, looking at our drill press, we had to tilt the table to line the hole up vertically. And then we also, on the table, we had to twist the part so that the entrance and the exit hole were straight up and down from each other. Here, what we are doing is we are taking the corner of the part and we're milling it off flat. Similar type of thing is going to have to be done. This part, on the mill, we're going to use some sort of probably a bevel vise rather than using a sine bar, but I'm going to set it up with a sine bar just because that's mathematically the easiest way to represent it. We're going to use something to get the right angle there, but then we also, on top of that, we have to rotate this piece so that that piece that's going to be milled off is flat, like that. So we need to figure out how far to rotate it here, and then we need to know how far to tilt it here. So this is going to be our angle of rotation. This will be our angle of tilt. So looking at this from above, when this is rotated correctly, this part right here will be parallel with this edge or the bottom edge of the sine bar or whatever platform we're using to tilt it. If in its relaxed position this would be lined up, then this angle right here is our angle of rotation. We just need to rotate it from here to there. Does that look right? It's assuming we're lining up this edge over here, right? So how do we find that angle? Well, if we're looking at this triangle on top, do we know any dimensions from it? Yeah, the dimensions we just found up here, the 23.56 is this side, which we'll put right here. The 30.78 goes right here. And this is the angle we're looking for. That's our angle of rotation. Now that could be put, either side really could be considered the angle of rotation. We're just using this one. But how do we find it then now? That would give us the length of that side. We want the angle. How do we get to the angle? Inverse tangent. Very good. Of? Perfect. Opposite would be the 23.56. Adjacent is the 30.78. So second tangent. 20, it's coming, 23.56 divided by 30.78. 37.43 degrees. So now we need to do an angle of tilt. That angle of tilt, if we're looking at this section here, and I'm going to draw it a little bit larger here, quick. If I can make it work. So there's that section. There's where our missing corner would have been if we hadn't cut it out. Our angle of tilt is the angle between this surface up here and the surface that we've cut off here. So there's a mysterious angle in here. In fact, what I'm going to do is draw that line across. It's this angle right here. The first question is, where does this line up here have to be drawn to make that angle come down from it? Because if you move that angle side to side, it will change that, or move that red line side to side, it'll change that angle. Well, that red line has to be perpendicular to this surface, because if this surface, if I'm looking here, if this edge is parallel with this, then the angle we're measuring has to come up off of that, perpendicular, to get our angle of tilt. So we first have to find this piece across here that is perpendicular there. How are we going to find that? Well, we've already found major pieces of it. We know that this side of this here is 30.78. We know that this angle here is 37.43. Now we used those pieces before working on this big triangle, but those two pieces still apply to this smaller triangle here. This one. Just this side isn't used anymore. So to find this length here, pull that triangle out. The 30.78 is no longer one of the legs, it's the hypotenuse over here. And the 37.43 is still just an angle, of course. And now the side we want is this one here to give us this. I'll label that as C for now, since we found A and B. How do I find side C? Well, if this is my angle, the 30.78 is which side? Hypotenuse. C is the opposite. Opposite hypotenuse make sine. So it's going to plug in there. My angle is 37.43 degrees. Opposite side is C, my hypotenuse, 30.78. So I'm going to cross multiply. Sine of 37.43 times 30.78. 18.71. That is this length here. Well, now what are we going to do?
You can take the dimension you just found and 10 millimeter dimension that drops down to the actual milled line.
Yep, this one.
And figure out the angle.
Perfect. What we now have this right triangle in here. That one that sits in there. A little hard to visualize, but yeah, we can pull that one out. We had this 10 centimeters or 10 millimeters, whatever you want to label it as. We had centimeters, so we'll keep it that way. That we gave is that vertical dimension. And we have the 18.71 that we just found up here. And we can now find this angle. How do we find this angle? Inverse tangent of
10 divided by 18.71.
perfect. 10 divided by 18.71. .12. So we have an angle of rotation of 37.43 degrees and an angle of tilt of 28.12. So let's do this again. See if I can't draw my picture again, maybe. I have faith in me too, just not much in my artwork. Okay, you guys talk me through this. Now, last time I gave you a dimension here. Normally I would not. But even though we're not given one, we've learned from experience that we can just pick one, make one up. Because it's not the dimension itself. We're not looking for any sort of lengths or anything. We're looking for angles. Since we're just looking for angles, all that really matters is the ratio of dimensions, which are going to be determined by the angles. So we can simply make one up there and use it to determine other angles. So what do you want to put in there? 10 millimeters, right? Now what?
Do the 10 divided by the
Okay, so 10, we'll call this A here. 10 over A equals tangent of 24 is what you're saying? Is that over 1? So what's that come out to be? 22.46. Okay. Then how about finding this dimension here, which we'll call B? So yeah, tangent of 32 over 1 equals 10 over B. So B is 16. Cool. Now what? Okay, so yes, we are looking at this one on top. What about it? Okay, what's this one? This is 16. Which one? That is what angle? That's rotation. So now what?
Inverse tangent of 16 divided by 22.46.
Okay, what's that give us? 35.47 degrees. Okay, now what?
Now we need to find the length parallel.
That one you mean?
Yeah.
Okay. So how do you find that one? Okay, what do we know?
We know the angle and we know the length of the hypotenuse.
Okay, perfect. We know the angle, that's still 35.47, and the hypotenuse is what this leg now becomes the hypotenuse when we cut it across there. How do we find C?
The sine of 35.47 divided by 22.46.
It'll equal C over 22.46. So technically it's times. Yep, which gives us .03. So what we just found there was this dimension right here. So what are we going to use that for?
We're going to use it to find the inner triangle. We have the adjacent and the opposite side.
So this is 13.03, this is 10, and this is our angle of tilt we're looking for. Good.
And that's simply the inverse tangent of 10 divided by 15.
Okay, and that gives us
37.50.
37.50 degrees. So again, what all this means, we have 35.47 there, is to put this on the mill that surface flat, we have to have some sort of a surface beveled at 37.50 degrees. And then on this surface, to line that up, that piece, if we're looking at it from this side, is going to have to be rotated 35.47 degrees on the bottom to make that edge line up. You get confused, Jason? You okay? Okay, well, I want you guys to try one now completely on your own. Try that. Plan my rotation and tilt. I'll give you about 10 minutes here. See what you come up with. 52.77, you said? 37.23. Anybody else being different? 52.77.
I'm looking at it.
Okay. What'd you get for this side here from this one? 24.75. How about this side over here? 18.81. So, one thing we know about this angle right here, our angle of rotation, is going to be bigger or smaller than 45 degrees. Well, how would we know? If this angle were 45 degrees, what do we know about these two sides? They're the same. So when this side is larger, this is larger than 45. If this side is smaller, this is smaller than 45. So in this case, because of the way I set up the angles here, this side is slightly larger, so this angle does have to be bigger than 45. So the 52 is probably, and the 37.23 is just what you found was this angle over here.
Yeah.
Yeah.
I switched them when I was doing the math.
Okay. No big deal. So now angle of tilt. That probably caused you then, if you use this side with it, caused you to find the wrong distance across there most likely.
Oh, yeah, the rest
Although
is
your tilt might be right on though, but just if you got things mixed up correctly, you still might have the right tilt. What'd you guys get for tilt?
33.72.
No, you didn't mix it up. You didn't mix everything up correctly.
I did a real good job of screwing it up.
Okay. Anybody else get 33.73? No? What, do you get something different?
Oh, for tilt?
Yeah.
I got exactly that.
Okay. Okay. Now what I want you to do in the packet I just passed out, page 410, 1 through 14, go through problems like this. Obviously, I don't want you to do all of them, but I want you to do the odds. So that's 1 through 13, so that's going to be 7 problems. Before you leave here today, I want number 1 and number 3 done. we have this here with the angular surface. Tomorrow, we will talk about intersections of angular surfaces to find the angle and length of an intersection of angular surfaces. And that will be it for the compound angles, which means depending on how things go tomorrow, whether we need to review this a lot or if we get right into the intersection of surfaces, we will have our unit test on this stuff either Wednesday or Thursday. I'm hoping for Wednesday because Thursday I would really like to start your final test for the class. So you can do that Thursday, Monday, Tuesday, and it sounds like you guys are doing shop cleanup Tuesday, so Wednesday might be kind of a light day down there for you. So hopefully we can make that work out for you.